we are going to discuss about alkynes in the hydrocarbons. So the topic 3 is, first is nomenclature, second is isomerism, third is structure of triple bond, and fourth is preparation. 4.1 from calcium carbide, 4.2 from vicinal dihalides.
Vicinal.
Vicinal dihalides. Fifth is physical properties, sixth is chemical properties, and 6.1 is acidic character of alkyne. 6.2 additional reactions.
Additions or reactions.
Additions reactions. 6.12 is addition of dihydrogen.
So where we have 5 types of reactions, addition reactions.
Yes, sir.
Addition of dihydrogen, then
Addition of halogens, addition of hydrogen halides, addition of H2O water, then the 6.
Polymerization.
And there is 2 types, linear polymerization.
under polymerization we have 2
and
types.
cyclic polymerization.
Linear polymerization and
Cyclic polymerization.
side. So we will discuss one by one. See, whenever you study any topic, you have to arrive at the topic tree. So this will help you like a checklist. So when you take that topic, you have to cover all these subtopics. These are all the concepts. Okay. So for any organic compounds, for instance, nomenclature, isomerism, structure, preparation, properties. Under properties, you have got physical properties, chemical properties. Then there will be some applications also. So all these are very, very important. But as far as alkynes are concerned, particularly in topic 6, that is under chemical properties, we have that is a major classification. What are those? Acidic character of alkyne that we discussed. Then addition. So these 2 are very, very important. Under additions, we have various examples like addition of dihydrogen, halogen, hydrogen halide, water, then polymerization. And there are 2 types of polymerization, that is linear and cyclic. So you must have the overview of the entire topic. Okay. Now we'll go for what you call the nomenclature. Okay. Now listen to me. As far as you can also write down simultaneously, alkynes YNE is the suffix. It means it has CC triple bond. And we have got already this alkyl group. What are those? If you have got 1 carbon, you can call it meth. Is it not? If you have got C2, eth. C3, prop. C4, pent. C5, bute. C5, pent. C6, hex. So likewise, oct, sept, oct, nona, deca. Okay. At least you should know up to 6. Hexa, that is hex. Now what you can do, you can write down all this. Methane, meth plus YNE is equal to methane. This is not a chemical reaction, but this is only a addition of prefix and suffix. So methane. Similarly, eth plus YNE, what is that?
Ethyne.
Ethyne. That gives ethyne. And prop plus YNE, what is that? Propyne. I hope now you can easily write down. Okay, can you write down all these things? Prop plus ine, propyne. YNE, not YANE. So always you must be very careful about the spelling. YNE, that's all. Then bute plus YNE, butane. Now the problem here is the methane is ruled out. This is not possible. Do you know why? Because let us consider the general formula. So the general formula for alkyne is CnH2n minus 2. So if there is only 1 carbon, you can put C1, and 2 into 1, 2 minus 2, it means that is CH0 0. So there is no hydrogen. So we have got only carbon. So it is not ethine, I mean alkyne. Okay. So methane does not exist because we need triple bond. After all, we have got already a symbol for carbon. Okay. So the first member is not methane, that is ruled out. Do you understand? And actually the first member starts from ethine only. It is not like a methane. Okay. So here ethine. So the first member is ethine, second member is propyne. Ethine with the 2 carbon atoms because eth means 2. Okay. So in this case, how you can do? That is 2 carbon atom with the triple bond. Ion means 1 triple bond. And fill up the valency H, H. That's all. So 1 plus 3, 4. You should have the valency 4. So what do you call this one? This is ethine. So likewise, can you write down the other structures? Try. Tenth standard students, you can also learn at least nomenclature part of it. Okay, nomenclature, isomerism. These are 2 important aspects in the case of 10th standard also. Okay, you can also learn. Right. No, why you have put so many bonds? You should write only 1 triple bond. Now listen. Eth, prop means what? Listen here. Prop means 3. So propyne. Excuse me. Propyne, that is 3 carbon with the 1 triple bond. Correct? So put 1, 2, 3. And go to the end. Put triple bond. Now fill up with the hydrogen. 3 hydrogen. Here only 1. That's all. Okay. Now can you write down butane. But means 4 carbon atom. Write 4 carbon atom. 1, 2, 3, 4. Where you have to insert triple bond. So the remaining is CH and you cannot put anything here. Now CH2, CH3. Got it? Pentine. You must always check the tetravalency of each carbon, okay? Right. Now, shall we try 2-pentyne? You can draw here. Two pentyne. Pent means 5 carbon atom. Write down 5 carbon atoms. Then 2 means the position of the triple bond. So from the right side you can bring. Triple bond you have to put. Erase other bonds. Don't put any other bonds. Why you have put that triple bond here? No, that you have to erase it. You must put only single bond, okay? Now 2 indicates the position of the triple bond. No, not here, this side. So, listen. So 2-pentyne. Okay? 1, 2, 3, 4, 5. That's all. 2 means triple bond is in second position. Count it. 1, 2, 3. Write down. 1, 2, 3, 4, 5 from left, from right. Now you have counted 5 carbon atoms and in the second position and third position. So you have to consider this as second position only. Do you understand now? So 2. Okay. Again write C, 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 C. So in the second position, write. Okay. Now fill up with the other bonds. What about this? 1, 2, 3. Here you cannot put any bond here. So 1, 2, 1, 2, and you can put here. Okay. So check whether you have 4 valencies for each carbon atom. You will not get here. Okay. Done. Now you can simplify. So CH3, CH2, C triple bond, C, CH3. Do you understand this? Okay. Now what is the general formula? Cn H2n minus 2. So this is 5 means C5, H10 minus 2 means 8. So you should have 8 hydrogen atom, 5 carbon atom. Please check. 1, 2, 3, 4, 5. So C5. 3 plus 2, 5 plus 3, 8. So H8. So the formula is also correct. Okay, write down the formula. Do you understand now? Can you write down 2-hexyne? Erase on the left side. Or you can write down here itself. 2-hexyne. Hexane இல்லமா hexyne YNE hexyne alkyne தான பார்க்குறோம். CH3, CH2, சொல்லிக்கிட்டே எழுது CH2,
CH3, CH2, CH2, C triple bond C, CH3.
very good. So what do you call it?
2-penhexane.
2-hexyne. Okay. So can you write down 3 hexane? Right. Here is the lower one. Here is the lower one. Ah.
CH3, CH2, C, triple point C, CH2, CH3. 3x.
You check whether you are able to get the formula. N is equal to 6. Got it? Right, very good. Now, can you, so what are the different types of a hexane we have given? 1 hexane, 2 hexane, 3 hexane. Shall we check 4 hexane? Please check. Is it possible? No, first write down the structure. Have you counted from right? Put the number first. No, you are left that C, man. You are left that first C. You are left that first C. Again, do it again. Erase. Draw first 6 carbon atoms. Now count. Now 4. Okay? Now listen to me. This is 4 hexane, but this is ruled out. This is a replica. This is the duplicate of 2 hexane. Do you know why? Because there is a rule called lowest number rule. So according to IUPAC, it is called lowest number rule. So this lowest number rule, it indicates the position of the triple bond here should be the lowest. So from the right, if you go like this, it is 4. From the left, it is 2. So you have to consider this as 2 only. It cannot be 4. You understand this?
Yes, sir.
But once you are taken like this to get the lowest, you have to maintain that direction only. Okay? So in this case, this is not 4 hexane. This is
2x.
again 2 hexane from the left. Okay? So strike out and rewrite. So this is called 2 hexane only once again. Do you understand now? Right. Then let me explain. another compound, that is 3-methyl. You can erase that right side. 3, whenever you put the number, you have to put the hyphen and start the nomenclature. So 3-methyl but 1-ine. Now listen to me. 1-butene can also be called but-1-ine. You can insert this substitution or the location of the triple bond here also. Okay, right. So first we will consider but-1-ine. And what about this? This is the substitution. Where it is substituted? Third position. And where is the triple bond? At the first position. Is it clear now? So write down the carbon skeleton first. But 1, 2, 3, 4. But means 4. And ine means triple bond. Where it should be positioned? Here, first position. So you have started already from here. 1, 2, 3, 4. So you have to go like this only. Now methyl group is substituted. Methyl group is CH3 is called methyl group. Okay. You have alkane, is it not? What is alkane? CnH2n plus 2. Methane, you know, this is methane. Ethane, C2H6. So likewise it goes, is it not? And alkyl group means CnH2n plus 1. That is 1 hydrogen is left. So it should be CH3 with a bond. This is called methyl group. This is a group. This is not a compound. This is a group. Do you understand this? So methyl group. So similarly ethyl group C2H5 is called ethyl group. Okay. So now you have methyl group is substituted. Where we have to substitute? In the third position. 1, 2, 3. See, as far as a bond is concerned, you have to consider in between bonds. As far as carbon atom is concerned, you have to count the carbon atom. So third position carbon, here you can put CH3. Okay. Now you can fill up with the hydrogen, right? So you have C. So best thing is again write, otherwise you will get confused. And you have put already CH3. Now fill up with the hydrogen. H. You cannot enter here and put H and here. H, H, H. CH3, C, H, CH3, C, triple bond, C, H. That's all. Do you understand?
Yes, sir.
So, what is this? 1-butene, and this is the third position. Okay. So you can mention like this. Now this is the first carbon atom, this is the second carbon atom, this is the third carbon atom, this is the fourth carbon atom. So 1-butene, that is but-1-ine, and this is 3-methyl. So 3-methyl. So you have to start from the substituent. This is called substituent. What is this? This is substituent. Okay. If you have got 2 more substituents, 2 or 3 substituents of different types, then you can adopt the alphabetical order. Okay. So likewise you have to proceed. So do you understand this? 3-methyl but-1-ine. Okay. Right. Next one. 3-methyl pent-1-ine. Can you try? 3-methyl pent-1-ine. It is completely. 3-methyl pent 1-ine. YNE. Proceed. So pent 1-ine. First you write down pentacarbon atom. Hydrocarbon. 1-ine. Triple bond. And then
3 CH3
ah,
CH2
CH.
CH3
Ah,
C triple bond CH.
very good. Okay. Now sometimes instead of giving this as a branch, they can also write like this. Now listen, you are written CH3, CH2, and then CH, CH3, and C triple bond CH. Okay, this can be written like this: CH3, CH2. You can put CH. Okay, within bracket CH3. It is understood. It is attached in the side chain. Then you can continue. That is C, then triple bond CH. And this can be represented in this way also: CH3 bond CH2 bond CH, where it is substituted as CH3 bond C triple bond CH. Okay. And you can represent by a simple bond line also: CH3 CH2 CH, and then you have C, and you can put like this. Now here also methyl group. It's a simple way to write. Okay, do you understand this?
Yes.
Got it? So you should be able to convert the bond line as a chain structure also. Okay, right. Can you write down, draw the structure of 4-methyl 2-ine, pent 2-ine. So what do you call this one? This one, 2-methyl pent 1, 2, 3, 4, 5. Tell me, 2-methyl,
2 methyl
2 or 3?
2 methyl
Previously you have written, no? 3-methyl, 1, 2, 3, 3-methyl. You have reduced 1. Pent means 5 carbon atom. You have not put 5 carbon atom. Rewrite. So 1, 2, 3, 3-methyl. Okay, 3-methyl pent 1. You have to be very careful. Pent-ine, pent, T, pent. Ah. Okay, right. Now try this one. 4-methyl pent 1-ine. 4-methyl pent 1-ine. Try. I told you it is a 1 pentyne. One pentyne. Now first you complete that pentyne. Now why you got confused? You have got 5 carbon atoms. Can't you introduce a triple bond in the first level? Why are you putting immediately H? Erase that H. Now fill up with the bonds only. Put the bonds only. Don't write anything, put only bond. Don't write H. Draw the bonds. Go step by step. I think got confused. Let me write. So you have to practice a lot. Listen to me very carefully. So the same thing we are repeating now. See, pentine. Pent. 1, 2, 3, 4, 5. This is the first. Hereafter you must write like this only. Then again, INE. Put 1, 2, 3, 4, 5, triple bond. This is the second stage. Third stage, you check for any substitution. What is the substitution? Methyl is the substitution. Again, 1, 2, 3, 4, triple bond, C. Now take the pencil and count the number 1, 2, 3, 4, 5. So it is in the fourth position. 1, 2, 3, 4. The methyl group. So introduce that methyl group. Do you understand? 4 methyl. Now we have completed everything. Fill up with hydrogen finally. Again write. So see, this is the way you have to practice. If you want to have any shortcut, you will fall down. When you learn anything, you must go systematically. Otherwise, you must be smart enough to do all these things. Now, CH. And what about this? I already put. You have to put the bond. 1, 2, 3. 1, 2, 3, 4. 1, 2. You cannot insert anything. So now you can put H, 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 H. Okay. Now you can add all these things. CH3. This is CH and CH3 and CH2. Then C triple bond CH. Now you can declare this as 1, 2, 3, 4. Okay. So this is 4-methyl pent 1-ine. You understand this?
Yes.
4-methyl 1-pentine. Now, see, can we call this as 2-methyl? Because lowest substitution. You cannot. Why? Because you already started numbering from here. So you should not change it. Once you have fixed means you should not change the direction. So in that case you have to go like this only. 1, 2, 3, 4, 5. So this is 4-methyl only. Okay? Right? Got it? Try this. 3, 3 dimethyl but 1-ine. Three, 3, dimethyl dimethyl but 1-ine. Try this. Erase completely other things. Remove all these things. Erase completely. No, you have to erase that one also. Right, proceed. No, you cannot do like this. Put CH3. Now it is already one butane. Why you have put two? You have put in the second position triple bond. I wonder really why you have put that triple bond in the second position. It is given as one only. Why you have put in the second position? Put the triple bond in the first position. It is given as butane 1. Proceed. You have to write CH3 on both sides, top and bottom. Remove that. Remove the bracket. You understand? Now fill up with the hydrogen. Now, is there any confusion for you to identify the position of triple bond? It is clearly given it is 1, but you have put into second position. Don't do that. Do you understand? Put H. Terminal H. Now you can rewrite CH3. No. Once again you are doing the mistake. CH3. No, C only. That is C only, is it not? You have to put CH3, CH3 only. That's it. Okay? Do you understand now? Right. And I think if I want to go one step ahead, you will get confused. Okay, let me stop with that. So you know very well 3,3-methyl but 1-ine. So do you understand now? Right, sit down. Now I'll teach you something about the structure of triple bond. Okay, take down. Structure of triple bond. Structure of triple bond. Let me take the simple compound, that is ethine, the first member, CH triple bond CH. Okay, that is C single bond, and this is triple bond C single bond H. Now you have sigma bond, and one sigma bond, 2 pi bond. Okay, so CH sigma bond. So sigma CH, how many? 2. And pi CC, I'm sorry, you have got one more CC. CC sigma bond is there. That is only one sigma bond. So totally 3 sigma bond. Okay, and here there is C pi bond, and you have another C pi bond. It means you have 2 pi bond, CC bond. So let us classify it completely. You have 2 CH sigma bond. Okay, and you have 1 CC sigma bond. Okay, and you have 2 CC pi bonds. Do you understand this? So triple bond is made up of single bond, one single bond and one double bond. That is triple bond. That is 1 sigma, 2 pi bonds. Okay, you know very well the sigma bond is formed in this case of CC by the axial overlapping. Okay, this is sigma bond. Pi bond means that is you got the sideways overlapping. So the vertical one. So here PZ, and you have this bond also. Okay, now let me indicate this pi bond by red ink. So this is the one. Okay, the another set is here. Similarly you have one sigma, p orbital. Now these two can combine sidewise, so this results pi. And another set is it can combine also. Okay? Are able to follow this?
Yes, sir.
Now I will show you with the some models also. Let me consider let us take this one. Okay, now listen to me. I have two pi bonds. Let me indicate with the two different colors. Okay, now listen to me. That is, z-axis is vertical. Okay, this is pz. So when I put like this is pz. Are you able to follow? pz. Then you have py also. Okay, let me call it py. And you have, so now this py can combine like this. Are you able to follow? So py can combine. You can call it x also. It is left to you from where you are looking. So that depends. Okay. So let me imagine these two are py. Okay. So this develop sigma bond because linear overlapping. Are you able to follow? So this results what? This is, assume that this is the dumbbell shape. Now, okay. So this leads to sigma bond. Is it clear? Right. And now let us consider this vertical bond, vertical orbital. That is here in this case pz. So pz combined like this. This is a sideways overlapping, is it not? So we can draw this like pz combined with another pz. Okay. So this results pi bond. That's what I had done. See, pz combined. So now combined. This is pi bond. What about this? Axial overlapping sigma bond, sideways overlapping pi bond. Got it? Right. You have one more pi bond. That is because of the out of plane orbital. Now see how to mention this is above the plane of the paper. You have got two lobes, is it not? So one lobe is below the plane of the paper, another lobe is above the plane of the paper. So it can combine like this, is it not? So it can come, pi bond can be developed like this. This is one type of pi bond and this is second type of pi bond. See that? And what about this? This is sigma bond. Got it? So it means what? That is, there are two possibilities. One is sigma bond, another is two possible pi bonds, sidewise and this sidewise. Do you understand? So this is drawn schematically like this. Is a perspective view. So that is why we put here, this is one combination. Okay, we can indicate this as one pi bond. The another set is, one is below the plane of the paper, another is above the plane of the paper. Below the plane of the paper, above the plane of the paper. Now you can combine these two. I hope it is very, very clear for you now. Right? So we have in a triple bond, two pi bonds and one sigma bond. Got this point? So this is the structure. Okay. So in the case of this one is above the plane of the paper, another lobe is below the plane of the paper. Okay. So likewise, there are two pi bonds. I hope it is very clear about the structure now. Okay. Then preparation part of it will continue the next class. Okay.